today we're going to talk about eclipses and the types of eclipses. But the first thing we need to do is talk about shadows, because there are different types of shadows. And if you have a handle on the types of shadows, you understand eclipses. So today, shadows. First, and the types of shadows. The types of shadows. First of all, what I want you to think about is a light, but not a big light, a light with no size. Now, it's hard to think about anything with no size because we don't encounter things with no size. But if you go out at night and look at the stars are so far away. I mean, they're light, giving off light, but they're so far away, they essentially are pinpoints of light. They have no size from our point of view. Of course, they're these giant things. But stars do not have any size from our point of view, so we call them a point source of light. Now, just to show you a point source of light, I cannot really do that in real life, but I can approximate one poorly. If we had a point source of light, there it is, a pinpoint. Look at that little pinpoint if you can see it. Let's say that's like a star. Has no size, still giving off light, no size from our point of view, of course. And let's do this. Let's put an object in the way, like a ball. So let's say here is an object. We're going to call it an object. Now, so it's kind of like this, like holding up a baseball and going out at night and holding it like in front of a star. Now, if you hold a baseball in front of a star, you're not going to see the star. So that, you know what that means is this, that starlight, which is going off in every direction, I'm going to show you starlight, imagine it going off in every direction. Let's say a ray from the starlight going this way, it makes it right by the ball, going that way. It should be a straight line there, sorry if it's not. A ray going this way makes it right by the ball. And if this, let's say your eye, you can draw your eye in here. Actually, I'll put your whole body in here. This is you. Let's say that's you standing there. If you're in this region where this ball is blocking the star, you're in a region of total shadow. We'll write that down. A region of total shadow. A region of total shadow is known as an umbra. Umbra, you know the word umbrella, to block, to cover? So an umbra is a region of total shadow. So if you have a star, a pinpoint of light from our point of view, and an object, you either, and hold the object up, you either are in the umbra, you can, or at least your eye is, you're either blocking all of the starlight, or you can see all of the starlight if you move the object away. There is no place where you can hold a ball and cover half of the point source of light because it has no size. You cannot cut something in half if it has no size to begin with. You just can't do it. So either you see the star or you don't. I mean, try that. Have hold up a ball to a star and try to see half of the starlight. Just close one eye and try to do it with one eye. No, you either see the star or you don't because it's a point source of light. Now, let's talk about where more action is. And that is if you have an extended source of light, kind of like this, a flashlight, or like the sun. Take a look. You see this light? I'll try not to shine it right in your eyes. This has some size to it, like the flashlight, the front of the flashlight. I know there's a bulb in there, but the whole surface where the light's coming out of is bigger than a point source. It's called an extended source of light. So let me show you this. Let's say something like the sun. Like the sun has some size to it. It's closer than other stars. We call this an extended source of light. Why? It has size. It's not just a point source. It's a big region of light, or at least bigger than a point. Well, now, let's put an object in, like our ball again. Let's show it. object, like a ball. Now what we're going to do is this. We're going to look at the rays of this light. Now the rays of light are going in every direction, right? Every direction, these rays of light. But let's take a look at some shadows that are going to be created. And then I can show you the flashlight and show you how this is going to work. Well, a ray from the top of this, of the extended source of light, that makes it right by the top of that, because this ray going this way would hit it, all right? And these other rays. So there are rays that are going all different directions. Take a look at this ray. This ray goes by the bottom of it and goes there, right? Well, imagine you're standing in here. And that's like the sun. It's like having a giant, I don't know, beach ball and holding it up and blocking sunlight. Well, you are still in this region, in a region of total shadow. Guess what that's called? Region of total shadow? Yeah, that's an umbra. So there's the umbra. But isn't it true that if you happen to be standing here or here, that you might be able to see the top of the extended source of light, but have the bottom be blocked by the object? Same thing here. Here you maybe see the bottom of this, but the top would be blocked. There's another region of shadow that we need to talk about. And the way we get it is this. We take a ray from the bottom and draw it by the top here of the object going this way. A ray from the top of the extended source of light, here's some light coming out going towards the bottom, kind of like, it should be straight there, going this way. Well, there's a region here where if you happen to be in this, you see part of the extended source of light. I can show you that right now. Look, if I were to put this in the way and have it block part of the light, you're not in a region of total shadow. You're in a region of partial shadow if it's blocking just a little bit of the light from your point of view. And that would be called not an umbra, but a penumbra. So let's write that down. So in green, right over here, this what I've marked this off. That is called the penumbra. The penumbra is a region of partial shadow. A region of partial shadow. Write that down. If that's cut off there a little bit, well, here, I'll move it. There. Region of partial shadow. Penumbra. All right. Now, I want to show you these. I want to show you these regions. Imagine, think three-dimensionally. This would be like a cone, and that would be kind of part of a cone. It's not just two-dimensional. It's not a two-dimensional region right over here. So, what I'm going to do is let's imagine this. Let's imagine we make a cross-section here and having these two three-dimensional objects. I'm going to turn this over. No, I'm not going to do that. It's a mess. Take a piece of paper. Put it right here. We're going to use our flashlight and our object, and let's see what we get. So take a look there. Look at the paper. Keep looking at the paper. Now what I'm going to do, turn the flashlight on. Look, so here's the flashlight. All right, flashlight. Here is the object. Now look at the paper here. I'm going to make some shadows. And take a look at this. Oh, can you see that? See what I'm doing? I'm holding this apart, so you're not able to see the flashlight and the object. But I'm creating the region I just talked about. Do you see that dark center region of that? Guess what that is? That's in the umbra. If you were in there, if I put a little bug, let me find one. There's some looks like flowers here. I think I saw a bug. Yeah, do you have? Oh, look. You see that?
You want that bug?
Yeah. There's a bug. We can just rip that flower. Don't. Oh.
I think you just have to pick up the bug.
No.
Oh, it's on there.
Oh yeah, it's on there. I don't want to hurt the bug. All right. Now look.
I'm not going to be able to see that bug.
Okay, wait. Let me just. I don't want to hurt the. Yeah, you can see the bug.
Why don't you just use like a little piece of lint or something?
Lint? It's not like realistic.
Oh.
Wait. That bug's dead.
Oh.
Look.
Yep.
Now, I did not do this. The bug on this flower that I saw the other day, it died. It's not the virus, you think?
Yeah.
No.
I'm joking about that.
I'm not joking. Okay, I hope not. All right. I'm not joking. Look. You see the bug? Right there. Now, if that bug were alive, now watch. You see the shadow? Now, do you see where the bug is? It's right in the center of that dark area. If that bug were looking, the bug would not see the light at all, because the bug is in the umbra. It would not see the extended source of light. But now, look, watch this. I don't know if you see this bug, but that's the bug right there. If the bug, I'm going to circle. I know you probably cannot see this bug. Yeah, I'm going to circle where it is. It's right in the center of that. Now, take a look. Now, I'll do this again, just so you see. So the bug's in the center. In case you don't see the bug, now watch. You see the very dark area right there? That bug would be in the umbra. Would not see the extended source of light at all, but now watch. Do you see that grayish area around it? You see it now? You see where the bug is now? It's not in the umbra. That's kind of like not quite as dark a shadow as the penumbra. The bug would be seeing part of the extended source of light. You see that? All right, now, I don't know if you see that, but, okay. It's on. Sorry, I wasn't trying to.
Okay.
Okay. That's okay. I can keep recording, right?
You're still recording.
Oh, okay. I'm still recording. So now, but look, I wanted to show you something else here. Now take a look at this. We just talked about, well, you saw the dark center, the umbra. You saw the penumbra. Now, what I want to show you is this. There's even another part of a shadow. There's another shadow. Region of shadow. Now watch. I said this ray. We talked about this ray to figure out where the umbra is. This ray that goes by the top of the object and keeps going. Well, it doesn't stop right there. It keeps going. Look at this. And this ray that goes by the bottom, it keeps going. So in reality, there's another region. There's another region. And this region, I will dot it in red. What's true about this region right here? It's another region of shadow. It's another region of shadow. But there's something kind of special about this, because think about this. If you're standing right here, very close to the object, take your fist out. Hold it close to your eye and see what happens. See how it looks. Doesn't it look big? But now, so it looks really big. So if you're very close to this object, it looks really big. It looks as big as pretty much the universe almost. Now start moving away from your fist. Take your head, move away from your fist. Doesn't your fist get smaller faster than the other things around it? So doesn't your fist appear to get smaller quick? So if you start walking away from this object, what happens is this. It gets smaller, apparently smaller. Until you get right over here, and as this object gets smaller and smaller, when you're here, this object, which was much bigger than the extended source of light. Sorry, there's a dog problem here. Let's do this. My wife will take care of the dog problem by taking care of the dog. All right. It's okay. All right, excuse me. Sorry about that. Rude interruption. All right, dog is out. So yeah, if you're very close to this object, it's much bigger, apparently, than the extended source of light. But as you walk away, this object gets smaller quicker, apparently, until you get right over here. And then if you look at the object size, the size of the object and the size of the extended source of light, Do you know what's true about their size from your point of view? They're the same, which means if you walk farther away from your point of view, once you get here, this object's not as big as the extended source of light. So you know what you see? You see a ring of extended source of light around the object, like a donut. You see a donut of extended source of light. Now, what is this region called? When a smaller thing moves in front of a bigger thing, it is called a transit. You may have heard the word before. I mean, to move across, a transit, like like a bus, a transit. So, when I took these classes from my dad years ago, my dad talked about this region being called the region of transit, or the ROT, which I thought, hey, that sounds cool. The region of transit, that part of the shadow, this region of partial shadow is called the region of transit. And then I started teaching it. I'm trying to teach it now. And then as I'm teaching this for years and years, at one point I said, you know what? I got to read about the region of transit in a textbook. I looked it up. I couldn't find it. I said, wait, where the heck is it in this book? And I looked in another astronomy book. Couldn't find it. I think, hey, if it's talking about eclipses, why isn't it talking about this? And then I went to my dad, and I said, hey, Dad, how come I can't find region of transit in any astronomy text? How come that term is not there? He said, I made it up. He said he made it up. And I said, what do you mean, Dad, that you made it up? You can't just make it up. And he said something like, why not? It makes sense. I said, yeah, it makes sense, but you just can't make up words. Well, you know what? I guess that's how words come about. People make them up. And then if enough people use them, it sticks. So now if you look up region of transit you go on an internet search, you'll actually find it. It's because probably my dad and I have used it so much, and other people use that term. Now it's a word. But there's another name for this region. Do you see how it's the opposite of the umbra? It's also called the antumbra. So, we can call it the antumbra. So you can call it the ROT, or you call it the antumbra. Either one you want. All right, there it is, antumbra. Now, can we create an antumbra? I'm not going to try it. I don't know if I can. You know what? I'm going to try it behind closed doors here. Well, actually, not behind closed doors, just to myself. I'm going to keep this to myself. And did I lose the ball? I think I may have lost the ball. Oh no! Actually, you know what? I have a marble. That's really not helping very much. Well, I do. I have the ball here. Let me see. You know what? I'm going to try to create. It here by doing this, and it's. Oh, you know what? Look at this. Yeah, here's how I can create it. Look down at the sheet. I don't know if you see this. I'm going to turn this light off so you can see it. Look. All right. Can you see the umbra? And can you see, now here's what I'm doing. We're getting farther away here. See the umbra and penumbra? Umbra, penumbra, umbra, penumbra. Now look at the very center. What's happening is this pretty soon. There's nothing in the center. That means in the center, right, the very center here, you'd be in the region of transit, the antumbra. So you can kind of see it. It's harder to see. Let me turn the light on again. So now you guys are experts at shadows. Good. Now, let's talk about the types of eclipses. I'm going to use the same paper here because I will probably use that circle. So let's talk about the main types of eclipses. Types of eclipses. Sorry about that sloppiness. Types of eclipses. Now, one is called a lunar eclipse. And two, solar eclipse. So we have a lunar eclipse and a solar eclipse. Let me show you the circumstances for a lunar eclipse first, because next time we're going to start talking about lunar and solar eclipses. And lunar eclipses are really nice to see, and I'm going to talk to you about some of the times you're going to be able to see some coming up. And solar eclipses are nice, but there's a certain type of solar that's it's indescribable. I'm going to try to describe it to you. I'm going to fail because it's indescribable. but I want you to see a certain type of solar eclipse called a total. One's going to happen coming up, and I will give you extra credit if you go see this. Now, you can't stay home and see this unless your home is probably somewhere in the Midwest or in the East Coast. But if you want to stay in Santa Rosa and see a total solar eclipse, well, I'll talk to you about that. That's not a good idea. So now, circumstances for lunar and solar eclipses. So now, first of all, let's talk about lunar eclipse. All right, lunar eclipse. How are you going to get a lunar eclipse? Well, first of all, you need the sun. Sun. Of course, you need to have the earth. I know the scale's off, the sizes are off, but who cares? Earth. And you also need to have moon. And I'm going to put the moon. Now watch this. There's the sun. There's the earth. I'm going to put the moon right here. Moon. I don't know if you can see that. Moon. So what's going to happen is this. Now watch what's going to happen. To have a lunar eclipse, so again, lunar, right over here, you're going to need to have sun, you're going to need to have sun rays, and you're going to need to have the moon go into Earth's, guess what? Shadow. Maybe the umbra or the penumbra. See the Earth's shadow? I'll just show the umbra right there. So to have a lunar eclipse, here's what you have to have. You have to have the Earth between the sun and the moon. Which means that the moon must be, what phase of the moon is it? If it's opposite the sun. Opposite the sun, you have to have a full moon. Full moon. Full moon to have a lunar eclipse. It's when the Earth is between the sun and the moon. And the moon is in Earth's shadow. So, lunar eclipse. If you want to write down something, yeah, maybe you should. You need to have a full moon. It's when the moon is in Earth's shadow. The moon is in Earth's shadow. And the Earth is between the moon and the sun. Now, let's talk about solar. And then we can stop for a while. I know there's a lot of talking. Sorry about that. Of course, you need the same culprits, the same players. You need the sun. You need Earth. But now, here's what you need. Of course, you need the moon. But the moon's not going to be full. It can't be on this side to have a solar eclipse. The moon has to be here. Moon. Because what you need is this. You need to have, watch, the angle's bad here. You need to have the moon's shadow striking Earth. Look at that. Moon's shadow striking Earth. So, what should you know about this? Well, what phase of the moon is that? It's a new moon. To have a solar eclipse, you need to have a new moon. It's when the moon's shadow hits Earth. We're in the moon's shadow. Right? The moon is going to be blocking the sun from our point of view. That means we're in the moon's shadow if the moon's blocking the sun. We're in the moon's shadow. Or the moon is between the Earth and the sun. That's how that's how you can get a solar eclipse. So if I were to ask you, what type of eclipse is it when the Earth is between the moon and the sun? Well, that's going to be a lunar. If I were to ask you what type of eclipse could have if you have the moon between the Earth and the sun, that would be a solar. But what if on a test? On a test, I might ask you this. What is it called when the sun is between the Earth and the moon? You see a problem with that? The sun is actually 4 times bigger than the distance between the Earth and the moon. So what would you call it if the sun were in between the Earth and the moon? I don't know. It wouldn't be an eclipse. What would it be? A disaster? Catastrophe? Can't happen? very bad day, extremely warm. So watch for some question like that on exam 4, just to see if you're listening. If I were to ask you, what is it called when the sun's between the earth and the moon? Yeah, that is not a good thing to happen. It doesn't happen. Doesn't happen. All right. Well, that's it for now. I've talked a lot. Hopefully this video came out. Sorry if I offended anybody with anything I said, but I'm going to stop the video right here, and hopefully this worked. And we're going to talk about lunar eclipses next time, and then it's backwards. Doesn't matter. I'm leaving it.
Okay.
It's backwards.
Are you done with
My wife just said it's backwards. This is the second attempt at this.
No. Probably for a lot of it, it's probably okay, right?
I don't know why would it be. I'm just
Okay, I'm going to say goodbye.
bye.